Now I'm going to look over some of the properties of logs and see how they can be used to either simplify or just change the way an expression is written. All of these properties come from a law of exponents, since again, a logarithm is nothing more than an exponent. There's going to be a law of exponents that corresponds to each. All right. So, for example, from exponents, we know that a to the n times a to the m is a to the n plus m. In other words, when we're multiplying like bases, multiplication turns into addition of the exponents. So the first rule for logarithms is going to be log base a of m times n. If you're taking the log of a product, again, multiplication turns into addition. So this will be equal to log base a of m plus log base a of n. All right. I'm not going to put this law to use yet. I'm not going to show an example of it yet. I'd like to get all, or at least several of the laws stated before I actually use them. So let's move on. All right. Next, we know from exponents that a to the n over a to the m is a to the n minus m, meaning that when you're dividing like bases, you subtract exponents. So what will correspond to that is the law that says log base a of m over n is equal to log base a of m minus log base a of n. Again, division turns into subtraction, and for that matter, subtraction can be turned back into addition. When we write these, they are not single in their direction, meaning multiplication doesn't always turn into addition. Sometimes addition turns into multiplication and vice versa. So it can go either way. So this first one is commonly called a product rule. The second one is commonly called a quotient rule. And then the next law from exponents is the one that says a to the m to the n is a to the m times n. In other words, when you raise a power to a power, it turns into a product. So the law of exponents that corresponds to that is the one that says log base a of m to the power p is equal to p times the log base a of m. In other words, an exponent that is inside the log function can move out front and become a constant, or for that matter, a constant that's out front can move up and become an exponent. Now, the way that these three laws are often used is to take an expression that is in a compact form and expand it, or if you have an expression that has already been expanded, you can compress it back down. All right, let's start with some simple examples. And I'm going to try to do examples where we move in both directions. All right, for example, if I had the natural log of 3y, since this is a product, products can become sums. So natural log of 3y is the same thing as natural log of 3 plus natural log of y. Here's a case of a product turning into a sum. Okay. On the other hand, if you had log of 7 plus log of 11, you could take this sum, turn it back into a product, and 7 times 11 is 77. All right, again, just depending upon your needs at the moment, products can become sums, or sums can become products. Moving on to some of the other rules. If you had the log of an a over 3, that could become log of a minus log of 3. And again, this a, let me write that a little bit better, is not a subscript, it's the a, all right? Not the sub, it's not the base, it's a log of a. So division becomes subtraction. Subtraction could come and turn itself back into division. If we want to do something with a little bit more detail, log base a of x cubed y squared z. What's going on here is we have exponents and we have multiplication. So this can become log base a of x cubed plus log base a of y squared plus log base a of z. So the multiplication has turned into addition. And now to incorporate the other property of logs that I haven't used yet, exponents can move out front as multipliers. This becomes a 3 log base a of x plus a 2 log base a of y plus log base a of z. All right. So what you will be asked to do, as I've indicated, is take expressions and break them apart. And you will also be required to put them back together. Let's look at one more that needs to be basically broken apart. If I had log base c of the cube root of y cubed z squared over x to the 4th, the first thing that would happen is the cube root would be dealt with. Cube root means 1/3 power, so a 1/3 can be moved out front as a multiplier. All right, on the top here we have multiplication. We also have division. So this will be a 1/3 times log base c of y cubed plus log base c of z squared minus log base c of x to the 4th. Next thing that happens is these powers get moved out as multipliers. So we have a 1/3, 3 log base c of y plus 2 log base c of z minus a 4 log base c of x. Then you can distribute the 1/3. 1/3 times a 3 is a 1. 1/3 times 2 is a 2/3. And 1/3 times 4 is a 4/3. And honestly, once you pull several of these apart, you should be capable, when asked, of putting them back together. All right, putting them back together should be very, very doable if you can pull them apart. For example, let's put some stuff back together. What if I had 1/2 log n, not base n, but log of n, plus 3 log of m? Well, the 1/2 will go back up as a power. And remember, 1/2 power means square root. 3 goes back up as a power. And then addition turns back into multiplication, right? And a lot of times when you put these back together, there's going to be simplification possible, right? For example, if I had the natural log of x squared minus 4 minus the natural log of x plus 2, remember subtraction will turn back into division. But in this instance, I have a fraction that I can do some work with. X squared minus 4 is an x minus 2, x plus 2, over the x plus 2, and the x plus 2's can cancel. So we simply end up with the natural log of x minus 2, all right? Also note that this cannot be simplified, broken apart in any way whatsoever. It would be, and I don't even want to write it down so not to confuse people, It would be completely incorrect to say that this is natural log of x minus natural log of 2 or something like that. You can't do it. There is no logarithmic formula where things are being added or subtracted like that is. So for that one, you're done, right? And those are the most basic properties of logs. They will be used extensively in later classes. They are very strange, a little bit odd for a lot of people when they first learn them, but you do need to get comfortable with them because, as I said, they will definitely be put to use.